Chapter 7, Section 2, Transposed Matrix and Linear Regression. Some of you may wonder why we need to learn the concept of transpose of a matrix for data science. To illustrate the usefulness of the transposed matrix in data science, let's consider regression analysis as an example. Let's consider a multiple regression model represented by this regression equation. Here, y is the dependent variable. x1 and x2 are the independent variables. Beta 0 is the intercept. Beta 1 and beta 2 are the regression coefficients for the independent variables x1 and x2, respectively. Epsilon is the error term, which indicates the variation that the model cannot explain. Suppose we have three observations, so the data can be organized as this data frame. Let's rewrite the regression equation in vector form. The dependent variable y can be represented as a 3 by 1 vector. The independent variable x can be represented as a 3 by 3 matrix. The first column represents the intercept. The regression coefficients beta can be represented as a 3 by 1 vector. It consists of the intercept and regression coefficients of two independent variables. And the error term can be represented as a 3 by 1 vector. It may seem that the order of the independent variables and the regression coefficients is reversed. But when calculated as a matrix product, it becomes clear that this is how it works. Therefore, it is correct to place the matrix of independent variables first and a vector of regression coefficients afterward. The regression equation represented by this matrix and vector can be simplified in this way. In regression analysis, the least squares method is used to estimate the regression coefficients beta. This method seeks to find a regression line that minimizes the sum of the squared errors. Through calculations using vectors and matrices, the regression coefficients can be obtained using this simple equation. In the first term, the transposed matrix is multiplied by the original matrix of independent variables. Let's explore what this means. Calculating the product of the transpose of matrix X and the original matrix X results in this matrix. The value of 3 in the upper left corner represents the number of observations. This value is the square of the intercept, summed as many times as the number of rows in the original matrix. The number of rows in the original matrix is equal to the number of observations, so it is the same as the number of observations multiplied by 1. The other two diagonal elements of this matrix represent the sum of the squares of the observed values of x1 and x2, respectively. These values reflect the dispersion of each variable. Among the non-diagonal elements, these represent the sum of the observed values. And these two values indicate the association between variables x1 and x2. The value of these elements tend to be larger when the association between the two variables is strong. When calculating the product sum of two numbers, combinations where both values are either high or low tend to result in a larger product sum than those where one value is high and the other is low, due to the nature of multiplication. However, the size of the product sum of x1 and x2 is influenced by the range of x1 and x2. For example, the product sum of variables that take values from 1 to 5 is likely to be smaller than that of variables ranging from 1 to 100, regardless of the association between the two variables. This tendency can be adjusted with the information of dispersion represented by the diagonal elements. In other words, this matrix includes information about the relationship between variables x1 and x2, and x1 and x2's dispersion. Thus, combining this information, this matrix can provide us with information about the strength of correlation among independent variables included in the regression model. The transposed matrix, also called transpose of a matrix, is a matrix which was flipped over the diagonal of the original matrix. It has several important properties that are useful in various mathematical and computational applications. In multiple regression analysis, the transposed matrix can be used to extract information of correlation among independent variables. You might think that the purpose of multiple regression analysis is to reveal the correlation between independent variables and the dependent variables, not between independent variables themselves. You are correct. However, in multiple regression analysis, the information of correlation between independent variables is also important. This is because strong correlation among independent variables can lead to a problem known as multicollinearity, which may lower the reliability of the regression coefficients. To obtain the information about the relationship between independent variables and the dependent variable in multiple regression analysis, we can use the inverse matrix. In the next section, we will explore inverse matrices. By understanding both the transposed matrix and the inverse matrix, your understanding of multiple regression analysis should deepen significantly. Thank you for watching. Please thumbs up and subscribe to my channel.